You see, I was talking about sequence number in the previous chapter. Sequence number. Every update, when it is sent out, every time a router sends an update, LSU or LSA, collection of LSA is what LSU. There is a sequence number sent along with it. And that sequence number will be +1 to the previous update. If previous update sequence number is 1, now the second update will be 2. For the sequence number, there is 4 byte represented in hexadecimal reserved. 4 byte. 4 byte number. And it begins with this and ends with this. Don't ask how. I'll explain, don't worry. How can it start from 8 and end with 7? That's a good question. What happens when this becomes F, which is 15? This next number will be 1 here and 0 here. And then 1 here, 1 here. 1 here, 2 here. Next, 1 here, 3 here. Likewise, at a point of time, it reaches F everywhere. As soon as it reaches F, this 8 will get resetted to 7 so that it can start from this again. Yeah, so that it can start from this one again. As soon as this 8 F, this all becomes F, it will get resetted to this so that the beginning number will become like this. That is automatic. That's automatic. Automatically it gets resetted. When the 8, all F's come. 0x8, F. It will get resetted to 0x7, F, so that it will start from 0x8, 00001. But I tell you, it won't reach this. Why? Every 30 minutes, the database is sent to everyone, which we learned in the previous chapter. Not only that, every 1 hour, all the routers will reset this to this number so that that sequence number will never get exhausted. You see? So every 1 hour, the sequence number will get wrapped. Right? So max age is there, just 1 hour only. You will not have that millions of updates within 1 hour. Not that bad network. No one is having that bad network. Millions of update. When will millions of update will come? When every now and then some changes happen. No, it won't happen like that. So this range is actually more than sufficient for 1 hour. That sequence number will never run out. All right. So when a router receives update from one neighbor but 2 different instance, how it will know which one is recent? With a higher sequence number. These things all we learned in the previous chapter in a flow chart. Same thing here in a written form. Any question from this? And now you see, when you type show IP OSPF database, you can see here the sequence number. What does this mean? This means from this router, this is the advertising router. From this router, 48 seconds ago, 8th update came, and that was regarding this particular network. 48 seconds ago, the 8th update came from this router. This is the router ID of that router, and this is the network. Link ID is nothing but the IP address on the interface. This is the router ID. In our example, both are same, but it will not be same always. In the screenshot from this router, they don't have any other network. So this network itself has become a router ID. Any question from this page? No questions? Now, you can see the inside of the packet by using Wireshark. You can also just type in this debug command, debug IP OSPF packet. It will show you the inside of the packet, but not the payload, not the data. It will show you all other information that you used to get from Wireshark. You see, it says it's an OSPF packet received from the router whose router ID is this. And it's an IPv4 OSPF. IPv4 OSPF is version 2. IPv6 is version 3. Guess பண்ணிருக்கலாமே, version 3. Version 2 OSPF is IPv4, don't forget. And what is this T1? Can anyone guess? This is what you are seeing there. You just saw version number, which is version 2. Type 1. Packet length will be there. Router ID you saw there. Okay, let me take you back there. See, packet length is 48 byte. Router ID, area ID 1. For area ID, how many bits are given? Can anyone say? In OSPF for area ID, how many bits are given? So area ID is 32 bit. Don't forget, area ID, you may write area 0, but actually it takes like this, 0.0.0.0. 32 bit. Don't forget. We don't type in this format. You just write some number, big number, like area 512. If you write like this, how it will be written in binary? 0.0.1.0. This is 512. Anyway, what I'm trying to say is, you try to recall what you saw there in Wireshark or what you have here in these boxes. This is what the debug shows. Version, type, length, router ID, area ID, checksum, authentication type, authentication string, and data. That's exactly you see here. Checksum, authentication. 0 means what? Null authentication. 0 means null authentication. Right? and there is no authentication string, and it is received on this port, serial 00.2. So someone called 10.00.12 is sending this hello packet. How I know it's a hello packet? Because it is type 1. Someone is sending a hello packet, and I received that on this port on this R1 router, right? So this chapter was about the packet types. Hello packet is type 1, database description 2, link state request is 3, link state request is 3, link state update is 4, and link state acknowledgement is 5. LSA is not link state acknowledgement. LSA is link state advertisement. This is link state acknowledgement. Okay, now we also learned that in a serial link, no DRBDR. Can anyone say what is the default priority on this port? Serial link we draw like this, P2P. What is the priority? 0. They never undergo DRBDR election because it is not necessary. So we are just going to paste this config on router 1. No OSPF so far. Let's go to second router configuration. Now, OSPF is not a new protocol for you. You have learned in CCNA. To configure OSPF, what we did in CCNA is we did like this: router, OSPF, process ID, network, 2.2.2.2, wildcard mask, and the area ID. So what this will do, this will go and match with the interface IP address. Whichever the interface that has got this matching will become part of OSPF process. So in our case, loopback 0 should be now running OSPF. Loopback 0. You see, loopback 0 only I gave that IP address. So let's verify whether loopback 0 is running OSPF. Now, to see the show command in some other mode other than privilege mode, you put do show IP OSPF interface brief. You can see that only interface currently running OSPF in process ID 1 in area 0 is loopback 0. The reason is I said match this. If any interface has got that address, run OSPF on that interface. Include that interface in OSPF process. Okay. But I tell you, this is classical way of configuring OSPF. This is custom way of configuring OSPF. We can configure OSPF straight on the interface also, like this. Interface serial /0 IP OSPF process ID area ID. Straightforward. You don't need to worry about wildcard mask, all the stuff. Go to the interface and say, I want whatever the address in this interface, I don't care. I want OSPF to be on this port. That's it. Now, if you put that same do show command, you can see serial also got included in the same process and in same area. And you see, I did not say anything like point to point. It is automatically taken as point to point. Why? I'll tell you why. Show IP OSPF interface serial /0. You see, it is saying status point to point. The reason is the encapsulation protocol for this interface is HDLC. Let me show you that also. Show IP, not show interface. You see, when I say show interface serial 0, the /0, it says the encapsulation type is HDLC. I told you if the encapsulation type is, oh, where did I write? It's not here. It was the presentation I was writing. I told you if it is PPP or HDLC, then OSPF will automatically take it as point to point. Network type as point to point. If it is Ethernet, it would have taken as broadcast. And you remember we were learning the timers. Hellos are sent every 10 seconds on this port for the serial 4/0, and the dead time is 40 seconds. Fine. Now let us go and configure on R1. Before that, I would like to enable debug. Debug IP OSPF packets. Now this is to show you the capture. Instead of showing on Wireshark, I'm showing here. Let's enable OSPF here. I can say like this: interface range loopback 0, serial 4/0. Okay, it won't accept. Okay, it won't accept serial in the range. No problem. Interface loopback 0, IP OSPF 1 area 0. Interface serial 4/0. Same command. Okay, now you see the neighbor has come. The router is identified with the number 2.2.2. It has got full adjacency with the router 1. And if you see here, the packets. Let me stop the debug. U all is the command to stop the debug. And if you go up, first come the hello packet. Version 2 means IPv4 version of OSPF. Hello packet. The length of the hello packet is 44 bytes. Router ID is 100.100.1. Area ID is 0. Checksum value, no authentication, so no string, and it is received on serial 4/0. And then came the DBD. And then again one hello, and then again DBD, and then LSR, type 3 is LSR, and then LSU is received. Query was sent by the query also received by this guy. Update also sent by the other guy, which means this guy also sent a query. Right? And then it is fully loaded. When there is no query, it's fully loaded and it reached full state. Right. So you can also use the debug to see all this thing. Let me show you. Show IP OSPF neighbor. You can see here full state. And what is this? This is priority. Please understand there is a difference in command. Show IP OSPF interface brief. This command and this command is different. This is process ID 1. When I configure OSPF, I say process ID, no, that ID. This is priority. priority on this interface. The default priority is 0. You can also see that in this command, show IP OSPF interface serial 4/0. Even here also you can see priority prior prior. Come on. Because it is 0, this version of operating system, it won't even list it. If in Ethernet link, no, it will show you 1 in this page. In the same show out command, show command, it will show you 1. This is not even showing because it's point to point. Usually it will be in this location, within this location, priority. All right, fine.